Hi and welcome to this quick how to help video on finding the nth term of a quadratic sequence. Now this is quite a big piece of algebra that we do. There's a lot of steps. The good news is that once it all clicks into place, then it is a fairly straightforward piece of algebra. They can't be that sneaky to us in the exam and make it any harder, really. So it's just a case of getting to that stage where you're feeling a bit more confident going through the steps. And hopefully this video is going to help you do that. So as with all number patterns, the first thing that we would do is we would look at the gaps, start trying to get a feel for what's going on. So when I look at the gaps of this number pattern, I can see it's going up 8, then 10, then 12, and then 14. So actually, what's happening is the gaps of this sequence is creating its own very sequence. So I'm going to repeat it and have a look at the pattern that I'm getting from that. That is giving me a gap of 2, another up 2, another up 2. So it's going to take me 2 rows of gaps to get to that point where the number repeats itself. And that's what I use to help me identify that I'm looking at a quadratic rule. So this is going to be an nth term where there's a power 2 on the n. And I know that it's triggered by the fact that I've got 2 gaps, power 2, 2 gaps. So I'm going to write that down straight away. I know my rule is going to have n squared in it. But at this stage, there is another detail that I have to look at. I do have to look at this last term, the last number here in the gaps, which is 2 in this case, and I have to half it. I have to divide by 2. Now, if that gives me 1, it means that 1 is going to get multiplied to my n squared to give me n squared. So actually, when I've got gaps of 2, dividing by 2 has no real impact on the nth term that I'm writing. So technically, don't need to write that down. But these are the sort of scenarios where it would be important. So let's say I had a final gap after doing the working out, and it was coming out 4 every time. That would mean I need to divide by 2, which gives me 2. So I would be writing 2n squared. If it was going up 10 every time, I must remember to divide by 2 to get 5 and put that with my n squared. So you can see that that divide by 2 step is really important if the number is greater than 2. But when it is 2, as it is in this example, it doesn't really have much of an impact over here because that will just stay as n squared. So once I've done that step, I kind of just take stock of what I've got so far. So I think, okay, my original sequence of 9, 17, 27, 39, and 53, these are the numbers I'm trying to find a rule to make. I want the rule to make these numbers. At the moment, I know my rule will have n squared in it. N squared generates me square numbers, yeah? 1 squared is 1, 2 squared is 4, 3 squared is 9. So the n squared is going to generate me 1, 4, 9, 16, and 25. They're certainly not the numbers I want. These are the numbers I want. These are the numbers I'm getting with that rule at this stage. So it's just not enough. It's falling short. So there's more to do. So at this stage, I am going to look at the difference between what I've got so far with n squared and what I actually want. So I always take, because it's about the difference, I always take. So I'm going to put a kind of takeaway line in there and perform 9 take 1, which is 8. And then we've got 13 and 18. Okay, so what am I looking at? I am looking here at the square numbers n squared gave me. Here, I am looking at what I've still got to generate. I still need a rule that's going to help me get these numbers. Now, I stopped after doing 3 because that is enough for me to work on. And I'm quite lazy. I'm not going to do all this extra work if I don't need to. So just the first 3 are all I really need. So there is a rule that's going to generate these numbers. And that's now the job I've got to do. So I look at the gaps. It's going up 5. It's going up 5. So this is repeating straight away with gaps of 5. So this is a basic nth term sequence where I can put the 5 with my n and then consider what's going to go on the end. Nifty way of doing that is to just go back. So I was adding 5 if I go forward, so I'll be taking 5 if I go back. 8 take 5 is 3. So it's going to be positive 3. And I'm just going to write that in black as well. So I have this being generated by n squared. I have this being generated by 5n squared. And these together, 8 plus 1 gets me 9. These together, 13 plus 4, gets me 17. So those two elements, n squared plus 5n plus 3, that is the nth term of a quadratic sequence. Job done. And it's those steps that we take every single time. So I am going to do one that's considered a little harder, just so that you can see it going through again. I won't talk with as much detail. I will just flow through it so you see how it kind of works. So I'm given 3, 6, 15, 30, and 51. I look at the gaps, goes 3, 9, 15, 21. That's created a pattern. So I'm going to look at the gaps of that, going up 6, going up 6, going up 6. So I've got 2 gaps. That tells me n squared straight away. Okay, 2 gaps, power 2. I must remember this sneaky little step and half that. 6 divided by 2 is 3. So I've actually got 3n squared. That is the first part of my rule. Now I just rewrite the original sequence, 3, 6, 15, 30, 51. And I'm going to write down my 3n squared. 3n squared is giving me 3, 12, 27. Okay, if you're wondering where that is coming from, I'll just quickly show you this one here. So why and how was that 27? The rule is 3n squared. 27 is position 3, 1, 2, 3. So it's position 3. So my n is going to be 3. 3 times 3 squared is, obviously 3 squared is 9, times by the 3 is 27. So that's where that came from, just in case you weren't sure. Then I always take, can't stress that enough, really important to remember that's the step. You can see I only did 3 because I'm lazy. That's going to be minus 6, minus 12. Don't panic. This is where you have to trust the method, okay? As long as I'm doing exactly the right steps, it can't go wrong. I've just got to trust that whatever comes is going to be solvable. And this is, okay? This is a pattern that will have a rule to generate it. So looking at that, I'm going to just change the color, I think. Looking at that, to get from there to there, I'm minus 6. To get from there to there, I'm minus 6. So I've got 6, minus 6 even. I've got minus 6n. Okay, do the opposite, which would be plus 6, taking me to 6. So plus 6. Now I've got the 2 elements that I need to write the rule. 3n squared minus 6n plus 6. So even when the numbers are feeling like, oh, I'm not sure, as long as they create the pattern that I can work with, I can write rules and it will work. So really good luck with your quadratic sequences. I hope this has been useful and I hope I am able to help you again in the future. Thanks for watching.